Hi, my name is Anna Lee Barnett. I'm a landscape ecologist with the Nature Conservancy's Center for Resilient Conservation Science. I worked on our freshwater resilience analysis for the Conterminous US, and I'm excited to share how you can interact with the results of this work through our Resilient River Explorer tool.
The Explore the Data tab helps users better understand a watershed's freshwater resilience score. You can explore the metrics and source data sets used to assess each resilience component. In this segment, I'll show you how to explore the connectivity element of the physical score. First, let's click on this diagram to see how connectivity fits in the overall model of resilience. We can see that connectivity and diversity, along with condition, make up the physical score of freshwater resilience. Green boxes indicate the metrics that were used to assess connectivity and diversity, while red font tells us the source data sets that are available for viewing in the tool and helping to interpret the metrics in green. Scroll to the bottom and click OK to close. Before I start exploring a river's resilience score in detail, I always turn on additional metrics and source data buttons so that I'll have access to this more detailed information. Next, I scroll down to map layers and turn on the state boundaries so I can zoom to my area of interest. Alternatively, you could type in the name of a river or other location. Here I'm going to zoom in to the Red River area along the border of Texas and Oklahoma. Once I'm zoomed in, I like to turn on additional layers for context. I'm going to turn on river dams, rivers, and functionally connected networks. Here is the Red River, and here is its functionally connected network in the dark blue outline. Currently, we're looking at the overall freshwater resilience scores, which you can see here by scrolling in the legend. Clicking on connectivity tells me that watersheds in blue score higher for their connected network size and physical diversity, while watersheds in brown score lower. You can always click the question mark icon to learn more about any element in the tool. I can see that this Red River FCN, this large blue area, scores high for connectivity and diversity, while one of its tributaries, Beaver Creek, scores low. Let's dive into the connectivity metrics to better understand the scores of these two systems. Expanding connectivity shows me that it's comprised of two subcomponents, functional connectivity and diversity. Let's click on functional connectivity. I can see that the Red River FCN score is very high or far above average for functional connectivity. Functional connectivity measures the size of the connected river network, accounting for the location of dams on rivers. I can see how big this Red River FCN is compared to the Red River tributary of Beaver Creek right here, which again is all fragmented by river dams, which is why it's scored lower for functional connectivity. Depending on the characteristics of a connected network, its functional connectivity scores could be increased or decreased. If we turn on this functional connectivity adjustment button and turn off the resilience score, we can see if an FCN received an adjustment and why it received that adjustment. Let's turn that off, turn our resilience metric back on, and move on to the headwater fragmentation component of functional connectivity. Headwater connectivity accounts for the fragmenting impact of dams on smaller streams and headwaters. I'm going to turn on the HUC 12 boundaries to help with interpretation of this metric. I can zoom in just a little bit here. Watersheds in brown are more likely to be impacted by the location of stream dams and watersheds in blue. If we open the caret for headwater fragmentation, we can turn on stream headwater dams. And we can see right away that indeed these two watersheds in brown have a lot of dams on streams and headwaters, especially relative to these neighboring watersheds in blue. So this watershed is likely being impacted by those small dams or dams on small streams. We can turn this metric off and take a look at diversity element of connectivity. Click on diversity, zoom out a bit, and I'm going to turn off those HUC 12 watershed boundaries. You can see right away that this is quite a different look than the functional connectivity scores. As a reminder, brown colors indicate values less than average for a metric. Let's see what's going on here by expanding the diversity box. We can see that diversity is based on temperature class and macrohabitat diversity. Let's turn on temperature class diversity. Okay, we can see that the Red River FCN is scoring slightly below average for temperature class diversity. Let's see why that is. We can turn on this mean summer temperature, and we can see by looking at the legend that pink indicates warm temperatures and green indicates cool warm. We can see for the Red River FCN, it's mostly got warm temperature classes with some green temperature classes. If we take a look at its tributary Beaver Creek, we can see it's only got one temperature class of warm. So it scores even lower for temperature diversity than the Red River FCN. Let's turn that back off. And we could take a look at macrohabitat diversity, just as we did for the temperature diversity component, but in the interest of time, we're not going to go through that. But again, you could explore just as we did with temperature. For more details on how the individual metrics were calculated, scored, and integrated into an overall connectivity score, click on More Info or Feedback, and then you can look at the project report for all those details. You can also provide feedback or ask questions via this link. This concludes my tutorial on how to better understand the connectivity component of freshwater resilience. Thank you.